Okay, this is the first question of LeetCode's 150 list. So it's called merge sorted array. Given two arrays nums1 and nums2 sorted in non-decreasing order, and the two integers m and n representing the lengths respectively, merge the two arrays into a single array in the same non-decreasing order. Also, note that you should be not you can't return anything, but rather store all of this sorted information within the nums1 array, and nums1 has been put so that it actually initializes to an array of m plus n, where the remaining like n elements are just zeros. So this probably prompts you to solve this question in constant space. So yeah, I'll be showing the optimal solution, which is time of n plus m and space of O of 1. All right, so here's the sample input. To generate and fill in the rest of these zeros, you would kind of think just, why don't we work upwards? So in this case, we see 1 is good, 2 is good, 3, is that good? Well, there's actually a 2 over here, so we actually have to replace this 3 with a 2. The reason why this approach doesn't work is because you just removed the 3, you're just losing that value that you can no longer put in. So that won't lead to the right solution. So how can we kind of avoid losing values? Well, you actually have to think in reverse. Let's work backwards. If we work backwards, we're actually not going to miss any values at all. So you see we can put a 6 here, we put a 5 here, then we would put a 3, so we actually use this 3. So it's okay now that we deleted it. Now we can put the 2, and then the remaining 2 and 1. So how can we actually do this in code? Well, it's using pointers. So for instance, let's have one pointer at the end here and another pointer at the end here. So now you want to see what guy should go here, and then just keep on decrementing it until, again, you just reach the very end. And then in that case, you would have filled the entire array in sorted order. How do we kind of maintain this sorted variant? Well, you have to kind of check, out of the two elements that the two pointers are on, which one's bigger? So in this case, it's the 6, which is why we'll put the 6 right here. Actually, I'll remove this element and just put the 6. Okay, now we're going to see what element goes here. Well, because we just used the 6, we're just going to decrement the pointer. So now we see what's bigger, 5 or 3? Well, 5 is bigger. Again, we'll decrement the pointer. What's bigger, 3 or 2? In this case, 3 is bigger, so we'll put the 3 here. And because we use the 3, we decrement that one. What's bigger, 2 or 2? It actually doesn't matter at all. I'll just put the 2 from the green side. So when I decrement the green side, you'll see that it's pointing at index -1. Whenever one of them reaches an index of -1, that means that you don't have to continue this loop, I guess. Just straight up fill in the remains of the remaining array. In this case, well, there's a 2 and a 1, so you actually don't even have to like shift this left pointer, because what are you going to do? You're going to just put the 1 right where it is, so it really doesn't matter. But yeah, that's basically the algorithm. Once this reaches -1, you would have sort of filled the entire array. Okay, first thing I'm going to do is make them indices. Right now, n is 3, but we really just want to deal with the index, so I'm going to decrement m and n by 1. Now, because we're kind of updating backwards, right, we want to get access to this index and then kind of keep on decrementing it until eventually we sort of fill out everything. So what is that current index going to be equal to? Well, n and m are 2 and 2 after we do the decrements. So this is actually index 5. So it's basically, I'll call it current index. It's n plus m and then plus 1. Okay, so now we're going to basically continue some loop while we're still fetching. So while we're still fetching from both numbers, we'll continue. And then once we kind of use all the numbers from one array, then we can stop this loop and just basically fill out the remains of the other array. So while m is greater than or equal to 0 and n is greater than or equal to 0. Eventually, when 1 hits -1, then you know you can stop. Okay, so we're going to do a comparison. So if nums1 at m is greater than nums2 at n, then we're going to basically put at our current index, we're going to put the larger number always, so we'll just put this number. Otherwise, if the other one is bigger or equal to, then we'll just put the other one. something to keep in mind is because we just used this, we can decrement our m variable. And same for here, we can decrement our n variable. And then now because we just updated the current index, we can decrement that as well. So now that one of them is finished, we can now basically fill in the remains of the non-finished array. So recall that if this one was, or rather if all of these numbers were finished, then when we're trying to finish the remains of nums1, well, there's no point, right? Because it's already in sorted order. Like, you don't really have to continue updating it. Versus if this was done, then you sort of still have to keep updating it because we're trying to manipulate nums1 here. So we only have to fill in the remains of all of these numbers. And this relates to n. So while the n is still greater than or equal to 0, we'll say just nums1 at current index equals nums2 at n. We can just decrement n and the current index. And that just fills out everything. We don't have to return anything, so I think that's it. Hopefully it works on our first try. Okay, seems legit. So this is, again, O of n plus m and O of 1 in time. And you can see it's pretty efficient.